I'm Dr. Marilyn Howarth. I'm will be joined today by my colleague Margaret Ferrandino, who's our Climate Change Fellow. We're from the Philadelphia Regional Center for Children's Environmental Health, a collaborative center between the Perelman School of Medicine and the Children's Hospital of Philadelphia. And we're doing this climate change webinar series in the hopes of bringing resources and information to teachers who can incorporate it into their classroom activities. And we're glad that some of you have joined us today, and we know that others will see this on their own. In either case, we remain available and happy to engage in questions either today or at another time about any of our content. And if we can help in any way, please contact us. Our contact information and social media will be on the final slide. So our purpose today is to explore climate change impacts on water specific to Philadelphia. We're in a lot of what we say will really have implications for out of the region as well, but really we'll focus a lot on Philadelphia. We'd like to do go into some detail about the impacts in our region, and we'd like to increase student and teacher understanding of these impacts on public health. We are a health agency, and so our lens will be public health, even as we talk about a lot of environmental issues. And we'd like to enhance your teaching toolkit with resources, curated reading materials, videos, and other materials that can help you teach this. You may have seen how different the impacts of climate change are depending on where you are in the country. There are places with extreme drought, and there are places with hurricanes, and places with temperatures that are over 100 now for 90 days or more. In our Northeast area, our key climate change impacts are flooding, increased precipitation, enhanced storms, heat, and also the air pollution that comes from that. And in our third webinar, we will be talking more about air pollution. But these are the sort of complex ways that climate change can impact health. As you have more extreme weather, you can see worsening air pollution, which then impacts asthma and cardiovascular disease. You can see changes in vector ecology. And by vectors, we mean mosquitoes and ticks and other animals that may carry those, leading to disease entities like malaria, encephalitis, chikungunya, Lyme disease, and West Nile. We also see with sea level rise and more water around, water quality impacts, leading to infectious diseases like cholera in the water and harmful algal blooms, as well as increased allergens and respiratory allergies and asthma as a result of that. The water and food supply are absolutely impacted by these both heat and changes in rain and precipitation. We can see places that had been fertile no longer being fertile, and places that were fertile drying up, and others really flooding and no longer being able to grow the kinds of crops that they're used to. The environmental degradation that comes from all of these things has been an important global factor in forced migration, civil conflict, and as you might imagine, repeated climate change devastation leads to mental health challenges in a lot of places. Heat-related illness and death and cardiovascular disease come with extreme heat. We're used to thinking of heat as being an annoyance or another hot day and just not being comfortable. But in fact, heat kills people. We talked about that in our last of our series. Injuries, fatalities, we hear about them when trees fall on homes, when people are electrocuted, when there's drownings due to rip currents. And so all of these really serve to be health impactful and something we need to consider. But when we think of water, it's a complex mixture of things. Climate change is significantly impacting water by altering precipitation patterns, increasing evaporation rates, accelerating glacial melt, intensifying those extreme weather events, and all of this together disrupt the availability, quality, and distribution of both freshwater and marine environments. We know that sea level is rising. It's doing that due to glacier melt and a whole variety of other factors. Higher temperatures are increasing the volume of the water in the ocean just because higher temperatures lead to more activity in molecules that actually simply increase the volume. More volume in the oceans results in this sea level rise, which cause erosion and flooding and damaged infrastructure and higher storm surges during these hurricane events. Many urban settings are located along coastlines and are being threatened with these rising sea levels. Bringing it back to Philadelphia, all of these blue, green, and blackish purple areas will be impacted at different levels of sea level rise in Philadelphia. The blue represents the area in blue represents 2 feet of sea level rise and a Category 1 storm. So a big storm, but not a huge storm, not the worst. But when we have 2 feet of sea level rise, all of those areas will be inundated. Lots of towns up and down the Delaware River, but in large part, southwest Philadelphia, which is where our airport is, and frankly, the entire area of Eastwick and Elmwood. And when we look at the opposite side of the droughts, as surface temperature increases, water evaporates from those surfaces. The high rates of evaporation dry out the soil so that it almost becomes an impervious surface. It's no longer that soil that you can pick up with your hand and drop in pieces. It is like a brick. The hard soil will then allow water to, rather than be absorbed in it, run off and again have tremendous erosion and also increase the force of that runoff so that the runoff will carry with it all kinds of debris, including contaminated soil if soil is there. And this will, in and of itself, decrease the availability of clean drinking water and interfere with food production. And the floods that we've had are in part due to an increase in evaporation. And that increase in the water in the air actually impacts precipitation. Precipitation occurs when there is a tipping point in the amount of water in the air, and then it comes out as some form of precipitation. Warmer air can hold more water, and so it tends to lead to more intense storms. And we have many more flooding events. I'll be showing you many examples of flooding as we go through. Here is a very local one when Ida flooded the Vine Street Expressway in 2021. As you might imagine, not only did did the street become impassable, but think about the redistribution of chemicals that were from the roadway and the surrounding areas that now moved to other places, moved into people's yards, moved into public places, and were left behind when the water receded. These are really significant kinds of impacts, potential impacts to human health when we're in an urban environment with many years of contaminated and legacy pollution in the soil. And more personally felt are the floods that happen in our neighborhoods in Philadelphia. Eastwick is one of those neighborhoods. Remember in the last map I showed the southwest Philadelphia area. Eastwick floods with some regularity. This Isaias was an extreme example of that, and there have been at least one a decade when this amount of Eastwick is underwater. You can see so many houses underwater, more than 120 water rescues on the day of this flooding event. Now imagine living there, having these major events, probably during the time when you've lived there, and in between smaller flooding, and not knowing whether that smaller flood, will turn into one of these big floods that ends up causing extensive mold contamination, property damage, property loss, and imagine the mental health toll that takes on people living there. And of course, this neighborhood is not the wealthiest in Philadelphia. In fact, it's one of the lower income neighborhoods in Philadelphia with a predominantly minority population. And I would say that their resilience in terms of being able to build back, is very taxed, especially when this happens over and over. For the rest of Philadelphia, we have another scenario called combined sewer system. About 60% of Philadelphia has this combined sewer system. And this is where under the ground, the sewage that comes from our homes is combined with the storm drain water that comes from the streets. And when it's sunny and dry out, all of that sewage from our homes and from the streets combine together, and all of that goes to the sewage treatment plant. And so it works perfectly fine. All of the water is then cleaned, and it then goes back treated into our waterways, no problem. But when we get an intense storm, and the amount of stormwater that goes into those storm drains dramatically increases, what happens is there is an outflow of the amount of water that is overwhelming to the treatment plant. So there is a certain amount of water that the treatment plant just cannot take. And so that ends up flowing untreated, so untreated sewage from our homes, untreated chemically contaminated water from our streets flowing into our waterways. And so this kind of pollution is something that we face in Philadelphia. We are not the only city that has this. There are quite a few across the country, but many of those places, including Philadelphia, are working to eliminate this kind of an outflow situation. The water department has a real-time app that you can look at. It's called CSOcast. You can just Google CSOcast. And if you go on this website, you can see each of these little blocks that I have on the map are places where these outfalls occur. When this image was taken, only one had an overflow in the last 72 hours. But on other days, you can easily see outfalls at all of these places in the last 72 hours. And so that is really significant when we think about the use of these waterways. Darby Creek, Cobbs Creek, a number of them where people recreate and certainly live along these waterways. And so what is the solution? There are probably a lot of different solutions that need to go together. But in a city, we have a lot of pervious ground. We have a lot of buildings, we have a lot of streets and sidewalks and concrete in general. And so anything that we can do to increase the green infrastructure can stop this overflow simply by absorbing more of the water that's coming in precipitation and allowing less of it to run off. And so this can be plants, it can be trees, it can be green rooftops, and all of these things in combination can help to mitigate the impacts of flooding. So here are what some of them look like around the country. They can be, small gardens in small areas. They can be a downspout that is angled to irrigate a garden underneath, collecting water instead of putting it into the sewer, actually using it as an irrigation tool. A green roof, or just sort of in a place where there would just be ground without much planting, putting in vegetation that might just absorb more of the water. And then there are pavement sidewalks that are pervious. They feel a lot like concrete, but they really allow for water to come through. And same thing in when you have large swaths of lawn, like on a golf course or something like that, you might put in a retention pond. And these are all strategies for green stormwater infrastructure. And in Philadelphia, we are doing this right now. And here are three good examples of the kinds of things that you can see in Philadelphia because they're here. I wanted to spend a little bit more time thinking about the impacts of flooding itself, since flooding is so can be so devastating. We've seen so many of these impacts on in the media recently. We know that there can be habitat destruction, largely due to erosion or to the force of water literally pushing out foliage and other habitat. There can be extensive pollution depending on what gets into the water. Soil can be contaminated that's left behind, and whole species can be wiped out as they're displaced. We know that our own personal infrastructure, our societal infrastructure, can be damaged. Roads, bridges, homes, lots of large-scale geographic changes, not just erosion, but true mudslides that take out a whole half of a mountain and sometimes entire towns with them. Power outages that lead to health effects in and of themselves. The mold growth that is left behind. Weakened foundations, so structures that we might use or live in that now maybe we shouldn't be because they're structurally unsound, and loss of property. Just to remind you of some clear examples of this, of washed away bridges. Excuse me. This is a grate with water it's supposed to be taking in water, but instead water is coming out of it, leading to flooding in this small area. And the displacement of species can really be animals. In some cases, they can be animals that are venomous and toxic and dangerous to us, and people. Sometimes people are forced to move and migrate because of these flooding events. They can be ongoing, lasting a long time, and completely destroy opportunities for farming and other pursuits. We've seen the catastrophic mudslides that can occur, really leveling villages. This one, literally, this all used to be green and houses, but now it's just mud because the entire side of this mountain slid down, covering up many of the houses that were in its path. So these are hard to predict sometimes, but often so catastrophic that we're really It's very difficult to prepare for them, and their implications require very large-scale emergency response. And then there are the perhaps more common occurrences of flood effects. And these are ones that we see all the time, and all the time in Philadelphia. When people have wet basements, or in the case of a flood where the entire basement was filled with water, if that water recedes quickly, say in 24 hours, and you immediately dry everything out, you can actually prevent mold from growing. But that is rarely the case. Normally, the water stays for an extended period of time, and the mold grows. And so here you see mold growing on pretty much every surface in this basement. This amount of mold would certainly need to be cleaned by someone who is a professional, because this amount of mold can make someone sick if they did it. Personal protective equipment, because anyone can be sensitized to mold. So even if you're someone without allergies, if you're around a lot of mold or around mold repeatedly, you can become sensitized to mold. And those who are already, we call them atopic. They have allergies already. People who tend to have a lot of allergies, these folks are more likely to be sensitized when they're in a moldy environment. And so they are more susceptible to having allergy, and then potentially even developing asthma as a result. So exposure to large numbers of mold spores, like for instance, that basement, if you didn't wear a respirator, you didn't have the right person cleaning it up, you could actually develop an acute situation, which is called hypersensitivity pneumonitis. This is an acute inflammation of many areas in the lung, simply because you breathed in millions of spores from mold cleanup. And it is a rare condition, but it's a very serious and life-threatening one. You may have also heard that mold can produce toxins. That is absolutely true. Some molds can produce toxins, but they only do it under certain conditions. And when they do it, the only proven health effect that occurs when they produce these toxins is a health effect that occurs when they are ingested. We have data from old studies that of people, starving people, eating moldy grain, in which a toxin was formed in mold in the grain, and they became extremely ill. But people in their homes, in these environments, they're not eating this mold, they're not eating the toxins. And so although they can have allergies and asthma, no one's getting the more serious kinds of illness that's described in the literature associated with the toxin. And as we mentioned, mold causes and worsens asthma for people who have asthma. So what can you do about it? Well, as soon as you can, you actively dry carpets, floors, furniture, hopefully within 36 hours, and that could even prevent mold growth. When you have more than a couple of square feet of mold cleanup to do, that needs to be done by a professional. They need to wear at least an N95. And even if you are cleaning up a small area of mold, you should wear an N95. You should discard or remove porous items that become moldy. And so by porous items, I'm talking about carpets, drywall, items like maybe books or fabric that can't be washed. If you can wash something in your washing machine, that's fine. But otherwise, those things where the mold is not just on the surface, like on the surface of a plastic container would be fine, but something that's really gotten into with porous material really does need to be discarded. And then when we have standing water, often the standing water is outside, we see Mosquitoes. Mosquitoes don't travel very far. They tend to, If the mosquitoes you see in your yard usually were born in your yard or in your next door neighbor's yard. They're just not from, they're not coming from across town. And they don't need a lot of water. Here is shown, it looks like a big puddle, but frankly, they really just need a small amount of water in order to breed. And West Nile virus is the most frequent illness that mosquitoes will bring us in Pennsylvania. Worldwide, malaria and other diseases are more common. But in our region, West Nile virus is the most important one. And as you can see here, Pennsylvania is in the highest category of cases of West Nile virus in 2024. So around the country, there are lots of examples of floodwaters being chemically contaminated. A really good example happened with Hurricane Harvey in 2017 in Houston, where it inundated 13 hazardous waste sites, not to mention all of the oil and gas infrastructure in Houston. And there were oil slicks, as you see in this picture, all over the place. So that was a massive redistribution of hazardous chemicals. But even in Philadelphia, remember we had the Philadelphia Energy Solutions refinery. Well, even though that infrastructure is no longer there, what is there is the legacy pollution in the soil. The soil is grossly contaminated with lead and with other petrochemicals, and flooding certainly can redistribute that. This is what it looked like when it was in service, and now most of that infrastructure is gone. But it doesn't have to be fancy. It doesn't have to be some big industrial process. It can be the regular old cars we have in our neighborhoods. Roadways and cars themselves are of oil, gasoline, radiator fluid, heavy metals, and yes, even asbestos. And so these contaminants, especially when cars are submerged by flood waters, can be distributed around in a neighborhood. And so floodwaters are never healthy to walk through, partly because of this chemical contamination, but also because of microbial contamination. So this schematic shows floodwaters, and under the ground there is a water table, and what that means is there is naturally occurring water under the ground, and it tends to be sort of at a certain level under the ground. Now, some places the water table is quite high and very near the surface, and other places it's quite deep. But wherever it is, at some point, this floodwater can meet the water table and actually get into the naturally occurring aquifer under the ground. Or if it doesn't do that, it can come into the top of a well where wells come up through the ground. In addition, the floodwater, of course, can get into homes and leave contamination there. The kinds of microbe contamination that we can see are bacterial, viral, and protozoa. These are all things that can make people sick if they consume this water. Severe weather, downpours with huge amounts of water, making flooding more common, have some other physical properties that we need to think about as well. Rushing floodwater is just that. It is a force of nature. It pushes cars. So if it can push a car, most people will be pushed along with this and end up drowning. It is very dangerous to go into rushing floodwaters. And so being trapped in a car in this circumstance or being trapped in the water can be very dangerous. We also see physical hazards like falling trees or falling electrical wires during storms. And rip currents. There's been a lot of discussion lately about rip currents, and I really wanted to mention this because um, depending on how comfortable and how often people go to the beach, they may only go once a year, and so may not remember that rip currents can cause many drownings. And the more hurricanes we have offshore, the more rip currents there are. And basically what happens with the rip current is there is this strong force moving out from the shore. And if you are caught in it, it can carry you out quite far. The calm person deals with it by simply letting themselves be pulled out. I'm guessing that's terrifying to do, but that is the guidance, to let yourself be pulled out and then swim parallel to the shore, get out of the area of rip current, and then swim back in. But people are dying due to drowning as a result of these rip currents with some regularity right now. So to review the impacts on public health, there are respiratory problems from mold growth, waterborne diseases like those bacteria and viruses that we talked about, injuries from all kinds of debris and falling debris, exposure to contaminated water, both chemically and microbiologically, mosquito-borne diseases, and other vectors that can bring us illness, the mental health problems of anxiety and stress of an impending flood, recurrent floods, the financial hardships that brings, the displacement and the property loss, really significant, this cumulative burden of cumulative flooding. And we thought this was a good graphic that kind of pulled everything together. The one thing that's on here I noticed that I didn't talk about yet was carbon monoxide. And generally, carbon monoxide poisoning happens when people are forced to use alternative electrical generators, or heaters, or some kind of an air conditioning unit that is run on a fossil fuel and is not adequately vented or is not kept outside. And so carbon monoxide then comes from these poorly vented fossil fuel burning items that people rarely use, so they may forget how best to use them, and they're carbon monoxide asphyxiation inside their homes. And so that is something to keep in mind if that is something that's used, in an intermittent way. So I would like to stop here and turn the presentation over to Maggie. Maggie.
Hello. So as Marilyn mentioned at the beginning, part of our purpose today is to provide materials for you to use in the classroom to teach your students about the topic of water and climate change. We put together a document of different materials for you to use, and what I'll do now is go over a few examples of the materials we found and then go over how to access the document. So first, for elementary students, we found several resources, including videos, activity workbooks, and diagrams. Here, the resource highlighted on the slide is a story that's online and free to download. The story is about Tommy the turtle as he prepares for a storm, focusing on the dangers of flooding and how to stay safe before, during, and after a flood. So obviously this book is great for all students, but will definitely resonate with those students living in neighborhoods that are prone to flooding and have probably experienced a lot of the things that Tommy the turtle goes over throughout the book. Next slide, please. For middle school, we actually have a resource that we have created ourselves. This is a curriculum for grades 5 through 8 on the impacts of climate change on the water cycle. Next slide, please. So the curriculum includes 5 lesson plans that each have their own materials, such as worksheets, PowerPoints, and activities. Starting with the water cycle, students then learn what happens to water when it hits the ground, how climate change is impacting the water cycle, the threats of flooding to Philadelphia, and then complete the curriculum with a lesson on resilience strategies to mitigate the impacts of flooding. We highly suggest this, looking into this as a resource. The content is aimed at grades 5 through 8, but the materials can be used at all levels. It's all available in a format that you're able to edit so that you're able to best fit the needs of your students. Next slide, please. And then for high school, one of the resources we suggest is the CSO CAS map that Marilyn went over earlier. So this is the combined sewer system overflow, and it's an interactive map showing the points of Philadelphia's combined sewer system with up-to-date data documenting overflow status. So this is a tool that can be used in the classroom for students to learn how to engage and interact with a map online, but also then how to record and analyze data to recognize trends over time. Next slide, please. So this last slide is the document I mentioned earlier. We organize the materials by grade and then provide numerous resources for each level. We listed the type of material, a link to the material, a short description, and then some suggestions for use in the classroom. Obviously, you are the experts in teaching, but we just wanted to help make your lives a little easier by brainstorming some ideas on how to use the materials. We will provide you with a link to a public folder labeled teaching materials, and then you'll have access to this document and many more resources to teach the topics of climate change in your classroom.
All right, so we'd like to thank you very much for attending the presentation, and feel free to reach out to us